Welcome back, guys. In the previous video, we were able to write down the steps in order to find the mathematical algorithm of the problem called CompuQuick. Now, in this video, we will be solving this mathematical algorithm using first Excel and then in the next video using Lingo. So, first of all, guys, I know that my decision variables are x1 and x2, and I'm gonna put them here in the cell called quantity. And then I know that my objective is to maximize the profit, which is 100x1 plus 150x2. Basically, guys, the profit per unit of standard was 100 and the profit of unit of turbo was 150, and that's why the total profit will be equal. Don't forget to put equal, guys, because this should be written here in order to tell you Excel that this is an equation. So it is 100, or in other words, it is this cell times x1, which must be posted here, plus 150 times x2 that should be posted here. Now, the constraints are that x1 is less than 100 because, in fact, x1 should be less than the capacity. So the capacity here is 100, and x2 is less than its capacity, which is 120. So this is the second constraint, which means that x1 here should be less than 100 and x2 here should be less than 120, and that x1 plus 2x2 should be less than the maximum labor, which is here 160. Okay, so in fact, standard needs only 1 hour of labor and turbo needs 2, and that's why the third constraint is that this one times x1 plus this 2 here times x2, and this should be less than 160. Now, this is the summary basically of the mathematical algorithm, and now we're gonna solve it using Excel. How? Let's do it. The first step, guys, in order to solve a linear optimization problem using Excel is to go into your home. Into your data. If you don't see the solver here, then you should add it. How to add it? You should go to File, and then go to More, go to Options, and then here, go to Add-ins, and then click on Go here, and then you should put a tick here for Solver Add-in. You can also put here a tick for Analysis Toolpack because we're gonna use it in the third part of this course. Now, whenever you click on OK, you're gonna see this under Data. So this is the solver here. Now, this solver will help us solve the linearization or the linear optimization problem. So I'm gonna click on Solver and Start. Okay, so I'm gonna reset all. Reset all means if I did this before, so if I indicate the solver parameters before, I should reset it all in order to start again. Now, the first row here in this window is to set the objective. So what is the objective? The objective is to maximize this total profit. So what I'm gonna do is to click here. If you click here, which is B5, cell B5, you're gonna see the cell here. And then you have to specify that you wanna set this objective to a maximum, minimum, or you're gonna set some value. Now, in my case here, I'm gonna have the maximum of this objective, the maximum of this profit. So that's why I have to click on maximum. By changing variable cells, which variable cells? Or in other words, what are your decision variables that you need to change in order to have maximum profit? In fact, these are my decision variables, x1 and x2. So what I did is to drag this cell here. So it is from F2, from cell F2 to cell F3. Even if I have 10 cells here, 10 decision variables, I can drag my mouse here and then I can indicate them in my variable cells. Subject to the constraints. What are the constraints? I should indicate here the constraints. So I'm gonna click on it. The first constraint, if you go back to your mathematical algorithm, is that x1 should be less than 100. What is x1? It is this cell. it should be less than or equal, so you should indicate here less than or equal to what? To this capacity. I'm gonna click on add. Now the second constraint is that this quantity here, x2, should be less also than this constraint, which is 120. And then I'm gonna say add. The third one, guys, is that if you go back to this document, x1 plus 2x2, which is the labor hours, should be less than the maximum labor hour, which is 160. So basically, it is this one, and this should be less than this one. And then I'm gonna click on OK. If you click on OK, guys, you're gonna see the three constraints that we indicated them in our mathematical algorithm. Now, do you have to make your variables non-negative? Yes, of course, they are positive. So I'm gonna click on this to make unconstrained variables non-negative, because I cannot say that I'm gonna do minus 150 standard computers. It doesn't make sense. So I should have a positive variables. I'm gonna keep this. This is the method. It is called simplex LP, and then I'm gonna say solve. You have, guys, to say that yes, I'm gonna keep the solver solution on the same sheet, all right? And then I'm gonna say okay. Then you can see, guys, that your total profit is 14,500,000. This is the maximum profit with a quantity of 100 standard and 30 turbo. As a first impression, guys, you can see that this is not logical, because I know that the turbo has the highest profit. So I should do more turbo than standard. However, guys, the turbo necessitates a lot of labor, of working hour, or of labor hour. And this has also a cost, and this has also a capacity. So that's why, guys, since I have a capacity for the total labor, which is 160, I cannot have only turbo. And that's why, guys, the values are here 100 for standard, because standard computers do not necessitate a lot of labor hours, and 30, although their profit, or the profit of turbo, is the highest. So basically, guys, before doing the solver, you can, for example, try, let's say, 30 for standard and 100 for turbo. And you can see, guys, that the total profit is 18,000, which is highest than 14,500. However, the total labor overcomes the maximum labor. It exceeds the maximum labor, so I cannot have this 100. So let's say it has 80. 80 also exceeds the maximum labor, so let's say it has 60. 60 doesn't exceed the maximum labor, however, it has a lowest total profile. I know that the optimized one was 1400, 500. So if you try, guys, you can see that this is the maximum profit, and it is the optimized value. So the